Hello class! How are you feeling today? Okay, are you all excited to learn new lesson about science? Okay, but before that, may I request everyone to please stand up for our prayer. Bow down your heads and close your eyes. Amen. Good morning class! Okay, before sitting down, please pick up those pieces of papers and arrange your chairs. Okay, is there any absentee today? Very good, no one is absent. So today, in order for us to be guided of the way things will be going in our lesson, we need to know first our objectives. Jenny, can you please stand up and read our objectives? Okay, thank you, Jenny. But before we will start our new lesson, last meeting class, we discussed about the different types of friction. So, as a sort of review, what is friction? Yes, Andy. Very good. Friction is the force which opposes the motion of an object. Now, who can give me the different types of friction? May I have Joanne? We have the static friction, rolling friction, sliding friction, and fluid friction. Now, who can give me an example of static friction? Yes, Carla. A floor. Okay, very good. Now, what about a sliding friction? Grace. Yes, poly dancing is one of the examples of sliding friction. Now, you can give me an example of a rolling friction. Yes, JR. Correct, when riding a vehicles. And who can give me an example of a fluid friction? Yes, Antoinette. Correct, a surfers. Okay, so do you have any questions and clarifications regarding our previous lesson? None? Okay, so I guess that you really understand our lesson last meeting. Now, let us start our lesson with a game. Are you familiar with a tug of war? Okay, so let's go outside and we will have our game. I have here a rope and a handkerchief to tie in the middle. I will split the class into two teams. So, Team A on this side and Team B will be on the other side. Understand? Okay. Now, each team should pull as hard as they can to try to make the other team fall or pull the handkerchief over a designated line. So, I guess that you are familiar with the tug of war and all you have to do is to try to pull as hard as you can. Okay? Okay, the last team standing will be the winner. And this will be done for 3 times. Understood? Okay. I will count 1, 2, 3 and then you can pull as hard as you can. Okay, are you ready? 1, 2, 3, go! Team A got 2 points and Team B got 1 point. So the winner is Team A! Now let us go back inside the classroom. Now, based from the activity that we have, what do you think will be our lesson for today, class? Do you have any idea? Okay, Karen. Very good. So today we are going to tackle about force and motion. Now, who can define what What is force? Okay, Anne. Very good. It is a push or pull of an object. What about motion? Teresa. Very good. Motion is a movement of an object. Now we will have a group activity. So this activity class will help you understand more about force and motion. But look at first the table, class. What can you see? Yes, there is a box. Now who wants to open the box and tell to the class what have you seen inside it? Okay, Raymond, please come in front. Okay, now what have you seen? Yes, so we have 3 toy car, marbles, 1 peso coins, ruler, and a glass. So these materials will be used in our activity today. I will divide the class into 3 groups. Now those who are sitting on the left side will be the first group. Those who are sitting on the center will be a second group. And then those who are sitting at the right side will be the third group. Okay, so each group will select a leader to present their work. And I will be the one to read the directions or the instructions of our activity today. All you have to do is to perform the activity, observe, and answer the questions. Did you get it? Okay, but before that, what are the standards to be remembered while we are having a group activity? Okay, let's read it all together. Follow the instructions. Cooperate with the group. Listen to the idea of others and be open-minded. Now, is that clear? Okay. After recording your observations and answering the questions, your group leader will present your work in front of the class. So this activity will be worth 20 points. And this will be the rubrics in giving your grades. Now, leaders, kindly get your materials and listen carefully to the directions. Are you ready? Oh, that's the spirit. So, first instruction, put the toy car and marble on the floor. Put the toy car and marbles on the floor. What happened to the toy car and marbles? Done? Okay. Second, push the toy car and marbles. Again, push the toy car and marble. Now, when the toy car and marble was pushed, what did you observe? Third, push now the table. Now, what did you notice? Again, what did you notice while pushing the table? Okay, done? Number 4, put the ruler on the top of the glass and put 1 coin each end of the ruler. Ibutang ang ruler sa babaw sa baso ug butangi og tag-isa ka coin sa matag tumoy sa ruler. Okay, did you understand? Did you get the instruction? Coins. Observe what happens to the equal coins. And then, add 3 coins to left side of the ruler. Okay, observe what happens to the unequal coins when put at the end top of the ruler. Again, observe what happens to the unequal coins when put to the end top of the ruler. Okay, I guess that everyone get the instructions well. Okay, now, I will give you 10 minutes to record and answer the questions. Start now. Okay, time's up. May I have the first presenter? Okay, so group 1 will be the first to present. Okay, now group 2. Okay, very good. Now group 3. Okay, very well done. So all groups have given their explanation well. You all have a good point. So let's give each group a wonderful applause. 1, 2, 3, wonderful. Okay, alright class. Let us go back again with your activity. Now, upon putting the car and marbles on the floor, did they move? What did you observe? May I have Joanne? Okay, it doesn't move. Why do you think so, Joanne? Correct, it doesn't move because there is no force pulling the car and the marble. Now, how are we going to make the car and marble move? Jerry. Very good, by pushing the car and the marble. Now, if we will apply greater force in pulling the toy car, what will happen to the movement of the toy car? May I have Angelo? Do you have any idea, Angelo? What will happen to the movement of the toy car? Very good. The toy car will move faster. Now, why do you think the toy car will move faster? Yes, Anna. Yes? Another answer. Okay, Alfred. Correct. So you too have a good idea. Because the greater the force applied on the small object, the farther it will move. Now, upon pushing the table, did the table move? Yes, Rose. Okay, yes. Now, what caused the table move? He went down. Very good. The force pulls the table to move. Do we have to apply more force in pushing the table? Yes, Giselle. Correct. Yes, because the table is big and heavy. Did you observe that in your activity? Okay, now what will happen if we increase the force pushing the table? Yeah, Shiny. Okay, so why do you think that the table moves a little only? Yes, correct, Shiny. The greater the force applied on a big object would cause less movement. Okay, now what about the ruler at the top of the glass with equal and unequal points on both ends? What did you observe? What happened when equal number of coins were placed on both ends of the ruler? Yes, Jonathan. Okay, why do you think that the coins did not move? Yes, very good. The coins did not move because the force are balanced. Was there motion when we place an equal number of coins on both ends of the ruler? Naabay motion? Exactly. Yes, there is motion. Why did the coins move? Yes, Rowan. Very good. The coins move because the coins are not balanced. Now, why did the equal number of coins placed on the end of the ruler did not move while the unequal number of coins move? Why? Karen? Yes, you have an idea. Another one. Okay, yes, Granny Rose. Very good. Class, the unequal number of coins placed on the ruler did not move because there is equal force. While unequal coins or the unequal number of coins move because the forces are not balanced. Now class, what makes the object move? Shiny. Very good. Force makes the object move. Now what is the result of applying force to an object? Mary. Very good. The result of applying force on an object is motion. Now, what will happen if we put greater force on a small object? Yes, Granny. Correct. The object will increase in movement. What will happen if we put greater force on a big object? Johnny. Excellent. There will be a small acceleration in movement. Therefore, is motion of an object depends on the force used in moving? May I have run? Exactly. Yes, because if we use greater amount of force, the greater the movement of the object. In general, everything needs a push or a pull to get it moving. So this push and pull is called force. A force can also slow something down or get it to change direction. Many things around us can move. Movement is also called motion. Motion is movement from one position to another. Now, do you have any questions regarding our discussion for today? Okay, if none, kindly please get 1/2 sheet of paper. Copy and answer this in a 1/2 sheet of paper. Are you done? Okay, please pass your papers in front. Okay, thank you so much. Now for your assignment, I want you to find the meaning of inertia. Okay, write it in your science notebook. Okay, so we will end our class for today with a prayer. Okay, Jeffrey, please lead a prayer. Amen. Goodbye, class. Okay, goodbye and see you next meeting.